Hi everyone, I'm Zhang, a PhD graduate from Monash University. I'm currently working at the University of Queensland as a postdoctoral research fellow. In the rest of the video, I'm going to introduce you some of my research works conducted during my PhD with the supervision of Professor Ranjit at Dynamics.
My PhD project is CFD-DEM modeling of proppant transport in hydraulic fractures in unconventional reservoirs. In deep underground, there are abundant unconventional geoenergy resources, including coal-bed methane, shale gas, hydro-fracking, and so on. To exploit these resources, hydraulic fracturing has been regarded as the most efficient technique to stimulate these reservoirs. There are two major objectives in hydraulic fracturing, that is, generating complex hydraulic fracture networks to enhance the reservoir permeability and making these fractures propped for a long time to maintain the high reservoir permeability. For the second objective, different types of proppant particles are mixed with fracturing fluid to prevent fractures from closure after the pumping ceased. Therefore, the study of proppant transport behavior in hydraulic fractures is of wide importance. Proppant transport in hydraulic fractures is a complex process that is governed by these impacting factors. Previous studies in proppant transport commonly used simplified experimental setups and simplified numerical models. This results in the challenges of considering some important impacting factors and conditions in real-world proppant transport process. To fill these research gaps, the major aim of my PhD project is to obtain a comprehensive knowledge on the transport properties of proppant in hydraulic fractures in unconventional reservoirs. Detailed objectives include to design and establish a novel experimental setup, to develop optimized CFD-DEM models, and using this setup and numerical models to systematically examine the impact of a variety of impacting factors and to elucidate the underlying mechanisms. The numerical method used in this project is CFD-DEM method. It is the coupling of computational fluid dynamics and discrete element method. In the CFD field, the Stokes equation will be used for calculating fluid flow. In the DEM field, the Newton's second law will be used for track particles movement. Generally, there are three types of CFD-DEM methods. The differences between these three methods lie in how they serve the coupling between particles and the fluid. They all have some disadvantages when it comes to modeling dense proppant transport in narrow hydraulic fractures. Therefore, during my PhD, I developed optimized unreserved CFD-DEM method, optimized semi-reserved CFD-DEM method, hybrid unreserved and semi-reserved CFD-DEM method. I also used VOF IBM to simulate the unsaturated proppant transport in hydraulic fractures. On top of that, I also developed a novel experimental setup for proppant transport study. In this experimental setup, the key components are the pressure seal and the clear fracture model. During the experiment, the proppant will be mixed with the fracture fluid in the pressure seal and injected into the clear fracture model. So here is the animation to the proppant transport process. Based on those developed numerical models and the experimental setup, I carried out detailed studies on proppant transport as listed in this table. Several studies have been published in peer-reviewed journals as listed here. Next, I would like to have an introduction to our group, 3G-DEEP Lab. 3G stands for geomechanics, for geoenergy and georesources. DEEP stands for the focus on deep earth engineering research and innovations. The leader of our group is Professor Ranjit Dynamics. UN Sustainable Development Goals 7, 9, and 13 are guiding principles at the heart of all our projects at the 3G-DEEP Lab. Our main objective is to develop and understand resource recovery in this domain, with the longer-term goal of promoting sustainable development of energy and resources. Looking back, I feel very fortunate to have joined the 3D lab and to have received the guidance of Professor Ranjit. He is a very warm person. Every time after our conversation, I would feel inspired and invigorated. Additionally, 3D is like a big warm family. During my time at Monash, my teammates brought me many wonderful memories. I'm deeply grateful for their companionship and support. That's all. Thanks for watching.